Yes, good morning, friends. Welcome back to the last class of our the series of lectures in mathematics. I know it is a very hectic schedule, and this content that we have covered till now in the last, maybe including today, 12 days, is the same amount that we generally teach in 5 semesters for B.Tech students. So the 5 semester syllabus crushed into 12 days. So I know it is very hectic and I know it is very difficult to follow also. That's why we are providing links for you, and we are providing the PPTs and all that. And I'm sure that these 12 days of this lecturing online is not just enough to break the gate examination, but what we present here is the salient features. We brush up your knowledge whatever you have learned earlier, and if not you have not learned any of the concepts that I have presented during these 2 days, these 12 days, then you can have an idea about those topics. That is the intention, actual intention, to brush up these concepts, revisit the concepts, and go back to your textbooks, standard books, go back to the standard books and prepare well for the examination. And repeatedly people are sending me mails that so it is going fast, or more problems and all that. Yeah, I am telling you, this is 5 semesters work, so content. Yes, we are delivering in 12 days. So that is the issue. So today I will be finishing off as I told you in the very first class, what all the topics common to all branches of engineering. I have picked up those topics like calculus, multivariable calculus, partial differentiation, multiple integration, vector calculus, linear algebra, differential equation, numericals, and complex variables, so on and so forth. They are the common papers. See, in particularly for CSE and IT students, very few topics are there that we have discussed here. But I think from 13th or 14th onwards, another session starts for those discrete mathematical structures and all that. Don't worry about that. That's what I'm informed about CSE people. So today, the last topic that we have, that is probability and statistics. Just let us have some idea about what has been completed till now. All right, quick access. Yeah. So if you see this syllabus once, so linear algebra, calculus, differential equation, complex variables, probability statistics, and numerical methods. So now we are dealing with probability statistics. Civil people also the same topics, almost all. CSE people have the linear algebra, calculus, and probability. We will be completing these things today, and discrete mathematics will be taken up shortly, and the schedule will be given to you. And ECG people, linear algebra, calculus, differential equations, vector analysis, complex analysis, numericals, and probability statistics. And triple also, transform theory is the only topic that is we have not discussed. That is because I said it's not a common topic for other branches, so I have not taken up that. Linear algebra, differential equations, complex variables, numerical methods, and probability statistics. So in a nutshell, we have completed almost more than 95%. We have touched upon more than 95% of the content. Of course, in a brisk manner, but that I cannot help it, because in 12 days I cannot do anything better than I cannot go at a lesser space, or maybe more number of problems as you have been asking me. So it is very difficult to finish off, to get things done in just such a short time. So anyhow, so today the only topic that we have left is probability and statistics. But if you go into the details of the probability statistics, very basic concepts are there. Now and all these things are not there. We have very basic ideas like definitions of probabilities, conditional probability, mean, mode, median, standard deviation, random variables, Poisson, normal, and binomial distribution. Of course, linear regression analysis there is only for chemical engineering branches. Testing of hypothesis there only for civil engineering branches, civil engineering students. And correlation regression is there for only ECE students. So that's why time is also is not permitting me. So I start this today. I will discuss these topics. I think it is very difficult to finish off these topics also only in a brisk way. Otherwise, even we cannot complete this topic. So we'll discuss definitions of probability, the basic ideas of probability, basic definitions, conditional probability, and then mean, mode, median, standard deviation, random variables, types of random variables, classification, Poisson, normal, and binomial distributions. We will just finish off these things. That is my schedule today. So let us go to probability and statistics. I can't say of statistics because I have I'm not going to touch the statistics, but for the basic idea of mean, mode, and median. So one thing I want to say very clearly is in GATE examinations, previous question papers, if you see every question paper without any, every year almost all, we are getting a question on mean, mode, and median. Okay, so just the very basics. We have done it in way back in 10th class, maybe intermediate also these things. Let's see what is these things. Why these are important for everybody is now the whole world is now revolving around data analytics and data systems and data analytics and so on and so forth. So even if mechanical and civil engineering students, if you have data, how to study the data, that is important. For a given data, the two basic things are measures of location and measures of dispersion. There are so many other things. These two things are very important for any distribution. If you say these two things are known, then you can talk about the distribution, at least in the basic level. One is measures of location. So location means the actual point where it lies. So then what is this measure of location? From the given data, so we have huge data, we try to extract several summarizing numbers. So question now is, data is a huge data, maybe different formats. The data can be sometimes given as a function, sometimes given as a scatter diagram, sometimes given as a bar diagram, pie diagram, so many things. So we try to now quantify the structure, the behavior of the data. That is the most important thing. When we quantify these things, then what we call extract several summarizing numbers. This is very important structure sentence here. Several summarizing numbers. Several summarizing numbers means from the data we study, we analyze and understand, and then we represent the whole thing with a number. That's what we call quantification. Several summarizing numbers that might serve to characterize the data set and carry some of its features. Once you quantify the behavior of the data, then you can characterize the data. Yes, this is the behavior of the data, and convey some of its features. Yes, the class behavior is so and so. The class is doing like this. This is the average of the class. This is the GDP of the people of India. This is the so on and so forth. These are the things that we characterize by summarizing with numbers of the given data. So measures of location, we have three important things. One is mean, the other one is mode, and third one is median. So what is mean? You know, we are very well familiar with very much familiar with this mean idea. Let us say I have n numbers, x1, x2, so on and so forth, xn n numbers. Then the mean of x1, we call also this as arithmetic average or arithmetic mean as x1 plus x2 plus so on and so forth, xn by n, that is or else sigma xi from I from 1 to n, xi by n. This is called arithmetic average. Then what is the physical interpretation of this x bar? It's just like in physics concept we have center of gravity. It just works out like that. It measures the location of the center of the set of numbers. It measures the center of the set of numbers. So that means, say for example, if 8, 3, 5, 12 and 10 are there, the mean is sum of the numbers by total number of numbers that are given in the problem. So 38 by 5, 7.6. I think you are familiar with this, finding the average. Maybe you are not familiar with some properties, but very much familiar with this arithmetic average or arithmetic mean. That's how we calculate this. Next, the numbers x1, x2, so on and so forth, xn occur the frequency, this thing, f1, f2, so on and so forth, fn times. Okay, so in a given data, x1 comes 50 times, x2 comes 60 times, x3 comes 38 times, like that. Okay, that's called frequency. How many times an event occurs, how many times a number appears, that's called frequency. So these numbers occur f1, f2, so on and so forth, fn times respectively. Then the arithmetic method, that means x1 comes f1 times, x2 comes f2 times, xn comes fn times. Then the arithmetic mean is, so I missed it. Okay, x1 f1 plus x2 f2 plus so on and so forth, xn fn. Then x bar is equal to f1 x1 plus x2 fn. What is it? The meaning is very simple. x1 is coming f1 times. So how many times x1 comes? 2. xn comes 3 times. So how many total events? x1 2 times, x2 3 times, 5 times. So like that. So x1 f1 plus f2 x2 plus so on so forth, the fn xn by sigma fn gives you the mean whenever the frequencies are given for the numbers. Then the sigma fi is called total frequency. So that means if you have 5, 8 and 5, 8, 6 and 2 occur with frequencies 3, 2, 4 and 1 respectively, then x bar is 5 into 3 plus 8 into 2 plus 4 into 6 plus 2 by the total is 10. That's how we get the frequency. And we have one more weighted arithmetic mean. This is very less known, but practically this is very important. When we use this, I'll tell you after few minutes. Sometimes the numbers x1, x2, so on and so forth, xn are associated with certain weights, w1, w2, so on and so forth, wn, depending on their significance or importance. In this case, x bar becomes w1 x1 plus w2 x2 plus so on and so forth, wn xn by w1 plus w2 plus so on and so forth, wn. So out of these numbers, let us say you need in your experiment or in your survey, you want something between, let us say x5 and x6 values, let us say some p1 and p2. You want this to happen. Most favorable things is numbers are between p1 and p2. So what we see is, for the data, we give more importance to those values very close to the required numbers, designed numbers, right? Then we give more priority to those numbers, to those data points. That means x, let us say x or xs. So then we give more weightage to them. That depends on the significance or importance in this case. So if a final exam, say for example, in JNTUK internal examination system, we have 2 internal examination. The best is given 80% of weightage, and the second exam will be given 20% of weightage. So 0.8 into highest internal plus 0.2 into lowest internal. That's a weighted average, because the significance means here we are using, depending on the significance means, the significance is student should be given advantage. So the advantage is whatever exam he gets maximum marks, that will be given priority. It will be given a significance and importance. So that is given 80% weightage. So if he scores less marks in the second examination, we don't give priority. So we give less weightage to that. So that's exactly the example for the weighted average. If a final examination in a course is weighted 3 times as much as a quiz, that's what the example I have given, and a student has a final examination grade of 85 and quiz grades are 70 and 90, find the mean grade. That means you want to give advantage to some stakeholder, particularly in practical examinations, then then what we do is, then we give some priority to that. That means here, if say for example one weightage is given to 70 marks, that is the first internal, first quiz 70, and one is 90, and then what happens? For the final examination, 3 times as the quiz. So 3 times into 1, that is 3 into 85 is the weightage to the final examination mark. So the total will be, the grade will be 83. Okay, that's how the weighted average is calculated. Then what are the properties? The sum of the deviations of the set of numbers from their mean is always 0. You take a set of numbers and find the average of that, and let us say if you subtract a particular each number, each data point from the mean, okay, then find the deviations, then the sum of the deviations is always equal to 0. Say for example 8, 3, 5, 12 and 10, mean is 7.6. So find the deviations of these individual numbers from this mean value. Okay, the deviations are 0.4 and 3.5 minus 7.6 minus 4.6, 5 minus 7.6 minus 2.6, so on and so forth. So if you sum up these deviations, you get 0. That is a very, very important property. If F1 numbers have mean M1 and F2 numbers have mean M2 and Fk numbers have mean Mk, then mean of all numbers, this is called pooled mean. Pooled mean, P-O-O-L-E-D, pooled mean. That means first 5 members have average something, next 5 members have some other mean, something like that. So then the X bar is F1 M1 plus F2 M2 plus so on and so forth, Fk Mk by F1 plus F2 plus so on and so forth, Fk. Then comes the median. The median of a set of numbers arranged in order of magnitude. That means if you put them in increasing order, either the middle one. So when does the middle one exist? When you have odd number, let us say you have 5 numbers, 2, 2 and central middle one is, third one will be the middle one. But if you have 6 numbers, this 2, 2 and central we have 2 numbers. So the middle value or the arithmetic mean of the 2 middle numbers, that is called median. After, mind you, remember that after putting them in the order of magnitude, put them in the order of magnitude, then if you have total odd number of elements, then the middle one will be the median. If you have even number, you cannot find the middle one. So middlemost, the 2 middle terms, whatever we have, take the average of those. So for example, you have how many numbers here? 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. One is the middle one, 4. You left leaving 4 here and leaving 4 here. So 6 will be the median. So on that number, 5, 5, 7, 9, 11, 12, 15, 18. Here we have 8 numbers here. So the middle 2 numbers are 9 and 11. The average of these two things will be, that is 10. That is called the median. And then, in fact, this is most important in practical aspects. Mode. Mode is the set of numbers. Mode of a set of numbers is that value which occurs with the greatest frequency. With greatest frequency, that means maximum the number that appears maximum number of times, that is called mode. That means the given experiment or data has a tendency, behavior that a particular value is obtained or attained more number of times. That means when a process is attaining the same value repeatedly, that means just you can understand the behavior of the given data. It is attaining the same value. So the whole process seems to approaching that point, right? So that's why this mode is very important in the practical aspects. So find mode of 2, 2, 5, 7, 9, 9, 9, 10, 10, 12. See, 10 comes twice, 2 comes twice, 5, 7, 9 comes 3 times. Okay, so the mode is 9. And if you look at the data, the more number of times a digit occurs, that means it has a more chance of occurring. So the process has an inclination towards this particular number. So for example, all the students in the class get 80% of the marks, more than 80% of marks, then you can talk about the class, they are doing good. Okay, right? And if you want to talk about the quality of the question paper, maybe relatively easy. If 80 out of the 100 students fail in the class, then we can talk about generalize the behavior of the data. Okay, so a distribution having only one mode is called unimodal. A distribution having only one maximum value is called unimodal. Sometimes even the mode may not exist. When does it happen? If all the numbers here they come only once. If all of them come only once, then you don't have any repeated occurrence, then you may not be having even the mode. So that's about all these things are about the location. Maybe mean, it's something like center of body, center of gravity. The median, when you put them in order, what is central location, middle point, that is what we call median, middle point, median. Mode, the number of times something occurs, that is called mode. So they are all measures of location. So next comes measures of dispersion or variation. So when you have data like this on real line, if you take numbers on real line, how much they are spread or dispersed, that's what we call variation, measures of dispersion. We have different measures for that. That's what we call dispersion, range of degree to which numerical data tend to spread about an average. When I say dispersion or spread, immediate question is dispersion or deviation from what? Deviation from what? Deviation from the average. You take the middle point, or maybe the center, or maybe the mean, or average, whatever you call it. From that average, how much the data is spread on both sides. And we measure that dispersion. That's what we call measures of dispersion and variation talks about. So degree to which numerical data tend to spread about an average value is called the dispersion or variation of the data. So we have two important things in measures of dispersion. There are so many things, but we are interested in knowing only in our discussion standard deviation and variation. There are so many like quartile deviation, skewness, kurtosis, how this gradually goes down and all that. So standard deviation of a set of n numbers x1, x2, xn is denoted by S and is given by S is equal to sigma I from 1 to n xi minus x bar whole square by n under 1 by 2 square root. So this is called the standard deviation. So this is also known as root mean square deviation because we are squaring the deviations and then we are taking the square root. Square root of squared deviation. X bar is the average value, xi is the set points. Then find the difference between the value of x and the average value, deviations. Square the deviation so that all these deviations are positive. Otherwise what happens? Some deviations are positive, some are negative. So xi minus x bar if you consider only, sometimes xi greater than x bar is positive. When xi less than x bar becomes negative. But when you sum up all those things, some are positive, some are negative. The total deviation may be 0 sometimes, but is it possible? No. So that's why to avoid that anomaly, what we do is we square the deviations of these numbers from the arithmetic mean or average, then find the average of that. That's why it's called square root of squares of the mean deviations. Okay, mean of square root of see the terms square root of mean of square deviations. Square deviations find the mean and then find the square root. Root mean square deviation. So if x1, x2, xk occur with frequencies f1, f2, fk, Then S is again when these have some frequencies, sigma I from 1 to n, fi into xi minus x bar whole square by n whole power 1 by 2. And then variance. It is defined as square of the standard deviation. Some people first define the variance, and standard deviation is defined as square root of variance. And some people define deviation first, and then the square of the standard deviation gives variance. Makes no difference, everything is same. It's divided by s square, sometimes sigma square. When we enter probable distributions in the statistics, we use sigma square. This notation is very important. This difference between sigma square and s square is very much important. Sometimes you use sigma square for population variance. For sample variance, we use s square. Sometimes as unbiased estimate, we use s cap square. So many things, s hat square, so many things are there. Find the standard deviation of 1, 2, 6, 7, 3, 15, 10, 18 and 5. The mean is find the sum of all those things, divide by 10, that becomes 8 values. That becomes x bar is equal to 9.5. So standard deviation is squares of deviations, the mean of squares of deviation under square root. So 12 minus 9.5 square, 6 minus 9.5 square, 7 minus 9.5 square, so on and so forth. Last term is 5 minus 9.5 square by 8. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8. Divide by 8 and then under square root. If you calculate that, we get standard deviation. And the square of the standard deviation gives you variance. These are the basic measures of dispersion that we will be discussing. And I have observed the question papers also. Yes, they are asking about these concepts. Like measures of dispersions, location of dispersions. And coming to the probability. So what is probability is basically we have an abstract idea when experiment is conducted. We have some possibilities and then we have probability. So if somebody asks you what is the difference between a possibility and probability, what do you answer? Possibility we know. When we do something, we have different options on different possible, and we are calling different options as possibilities. So this can happen, this can happen, this can happen. Okay. So if we quantify the occurrence of this possibility, the quantification again, each possibility is, say for example, is quantified, then we are calling it probability. So the sample space of an experiment is denoted by S. What is sample space? When you conduct an experiment, we have all possible outcomes. When you toss a coin, we have two options, head and tail. So those two things, as I said, is called sample space. If you throw a die, the possibilities are 1, 2, 3, 4, 5, 6. That is a set of all possible outcomes on the experiment. So that's called a sample space. So sample space is the set of all possible outcomes of an experiment. We call it a set. So if two coins are tossed, what are the different options? You can have head head, head tail, tail tail, and tail head. So this is our sample space. So then from this sample space, how we define the probability? An event, then comes the probability on event. We frequently use probability of an event. Then what is an event? An event is any collection of outcomes of S. Take any collection of outcomes of S, a subset of S. An event is simple if it contains exactly one outcome. We call an event a simple event if it has exactly one outcome, and we call it as compound event if it has more than one outcome. Okay. If A is subset of A S and A complement, the complement of A is the set of all outcomes in S that are not contained in A. A is subset of S, all that which is not A. Okay. Remove the elements of A from S, that is called A complement. Everything other than A, that is called A complement. Then A union B. Set theory notation we have done good amount of these works already at intermediate level and so on and so forth. A union, but in probability we need this concept, that's why we just revisit these concepts, that's all. A union B means either A or B or both. So A is some elements, B are some elements, then A union becomes these elements and these elements both together. That's called A union B. When I say and A intersection B, it means common elements of A and B. Both A and B. A should happen and B should also happen simultaneously. So common elements of A and B, that's called A intersection B. If A intersection B is 5 means null set, it has no elements, then A and B are called mutually disjoint. Say for example, if I have set here, I have set here those things, they don't have any common point, they are disjoint sets. Like that, I have some set of points like this, I have some set of points like this. So we have a commonality, right? Some points are common. Then we said that is not A intersection B is not a null set in that case. Given experiment, sample space yes. Now we are coming to the definitions of probability. Given experiment yes and its sample space, the objectivity of probability is to assign each element to each event a number P of A. Okay. So we have an experiment yes. We have an experiment and a random sample space yes, and now let A be an event, and to each, for that matter, to each event defined in S, if you can define a number, real number denoted by P of A called probability of A, which gives a precise measure of the chance that A will occur. So A is a subset of the sample space and A has some occurrence. Sometimes it happens, sometimes it may not happen. So it has chance of occurrence. That is a possibility. Occurrence of A, it has a possibility. And for that possibility, we are quantifying. Yes, if it is possibility is there, how much it is possible? That is the exact question. How much it is possible? Yes, this is possible with that number. That number is probability. We quantify the possibility of an event that is given by probability. So to each event A, a subset of yes, we are assigning a number P of A, that's we are calling probability of A. Then probability of A, to define the probability of A, we assume some basic assumptions as called axioms. We don't have proofs for the axiom, just we can verify them if you want. If A is an event, then probability of A is always greater than or equal to 0. At most worst case, what can happen? The event does not happen. That is 0. So P of A is greater than or equal to 0. Then probability of the sample space is equal to 1. And if E1, A2 are two disjoint sets, then P of A1 and A2 is equal to possibility of A1 and possibility of A2. For any event A, probability of P of A complement is equal to 1 minus P. These are the basic understanding that we go with this axioms of probability and the related properties before defining the probability. Okay. So probability then, if there are m equally likely possible, this is a very important point in probabilities. If they are not equally likely, then there is no point in discussing probability. If I have 10 students, 10 candidates for the interview, and one candidate is highly recommended, he is every chance of being selected, then we need not talk about the probability of one person being selected. Right? So it says some force is there for that. It's not equally likely. Okay. If there are m equally likely possibilities, of which one must occur, and S are regarded as favorable, are called successes, we call them successes, then the probability of a success is given by S by M. M are equally likely, and out of which S outcomes are favorable to. That means when you throw a dice, and if you want to have an even number, different possibilities are 1, 2, 3, 4, 5, 6 when you throw a dice, right? When I say I require a even number, the possibilities are 2, 4 and 6. Okay, 3 options we have. Out of total 6 options. So your probability comes out to be 3 by 6, that is 1 by 2. Now come on, tell me, if I throw a die, all possibilities we have, possible outcomes 1 to 6, have equal chance or not? Yes, they have equal chance. Unless until you add some gum or something like to one of the sides, then that time turns up, that only that side turns up or turns down, then it cannot be called as a experiment with equally likely possible events, right? So that's what we mean by this phrase, equally likely possibilities. The main drawback of classical probability is its limited applicability. It is limited applicability, as in many cases various possibilities are not equally likely. That's what I was telling. Various possibilities are not equally likely. In such situations, it is preferred to use frequency interpretation of probability or frequency of success to find the probability. In such case, what we do? We use the frequency interpretation of probability. What is this frequency interpretation? The probability of an event is the proportion of times the event will occur in a long run of repeated experiment. You conduct an experiment 100 times or 1000 times or 10,000 times. How many times the success comes? How many times the success comes? Let us say X times it comes, success comes out of 100 times. So your probability of success is X by 100. Say for example 60 times you are successful out of 100 trials. So your probability is 60 by 100. It is more practical than having your probability of winning is 1 by 2, 1 by 2. In usual sense, classical sense, what is the probability of winning a match? 1 by 2, 1 by 2. Okay. But in practical aspects, how many times Zimbabwe may win a match against Australia? Yes, 1 by 2, 1 by 2 in the classical sense. But in the practical sense, what happens? How many times they have played earlier? How many times Australia has won the match? And then from that, we get an assessment of the probability. That's called frequency interpretation. And our next point is, if A and B are any events in S, then probability of A and B is equal to probability of A plus probability of B minus probability of A intersection. This is called addition, law of addition. And if A and B are disjoint, then A intersection B is by a set. This is one set, this is one set here. Okay, they don't have any points in common. So A intersection B is fine, null set. Then in the addition law, this probability of A intersection B becomes 0. So P of A and B is equal to P of A plus P of B. Then we talk about conditional probability. Conditional probability, as the word says, conditional. That means one event happens and the other depends on that, or other event follows that. Okay. If A and B are any events in S and P of B not equal to 0, then the conditional probability of A given B means it is B already given that it happened. It is given that it happened. Given that B happened, then what is the probability of A? That is conditional. What is that condition? Yes, B has happened already. Now what is the probability of A? Then that is given by probability of A intersection B by P of B, where P of B is not equal to 0. So multiplication rule. So if you want to reach the class in time, you have to catch the bus in time. So now question is, if you catch the bus in time, what is the probability that you attend the class in time? Okay. So your attending the class in time depends on you catching the bus in time. That's an issue. That's how this conditional probability can be interpreted. So multiplication rule. If A and B are any events in S, then probability of A intersection B is, just cross multiply this, P of A into P of B given A, provided P of A not equal to 0, or P of B into P of A given B, provided P of B not equal to 0. This is what we are calling multiplication rule, a consequence of conditional probability. So we say that the event A is independent of B if A given B is equal to P of A. So when I say P of A given B is equal to P of A, that means in the final result B is not playing any role. That means A is not depending on B. Or B is said to be independent of A if P of B given A is equal to P of B. That means A is not playing any role on B. So we say that they are A is independent of B or B is independent of A. If two events A and B are said to be independent of each other, say coming to the multiplication rule, P of A intersection B is equal to P of A into P of B given A. That means let us say A and B are independent. So P of B given A becomes P of B. So this becomes P of A into P of B. Similarly, if A and B are independent, P of A given B is equal to P of A. So P of A intersection B becomes P of B into P of A. So this works out as a test to check two events are independent or not. P of A intersection B is equal to P of A into P of B. Then you can say the two events are independent of each other. So let us do some problems. Till now what we have done is fundamentals of probability, then simple principles of probability. I am not going to the permutations and combinations. Time is not enough for that. So then we discuss conditional probability, multiplication rule. That are the three important things that we have done. Basic probability, conditional probability and addition and multiplication rules. Let us do some problems on this before going to the next topic. What is the probability that at least two 9s appear as sum in four tosses of a pair of fair dice? There's a mistake here. So 9 occurs how many ways? 3, 6. Total number when two dice are thrown, what are the total number of outcomes? 6 square, 36. Out of the 36, how many are favorable? Favorable means here I want to get a total of 9. The first dial having 3, second 6, 4, 5, 5, 4 and 6, 3. So what is the probability? It comes out to be 4C1 by 36C1 or 4 by 36 or 1 by 9. So Q becomes 8 by 9. That is the first part. So in the second part of the question, at least two 9s. That's the question now. At least two 9s appear. That is the question now. At least two 9s means you can have two 9s, you can have three 9s. Okay, or four 9s, because it's tossed at 4 times. Maximum you can have is 4 number of 9, 4 times 9, 3 times 9 or 2 times 9. But at least 2 means what we mean by probability of 2 9s, probability of 3 9s and probability of 4 9s. So P is 1 by 9. So Q is, that means not having a total of 9 is 8 by 9. So 2 Qs out of 4 trials, you want to have 2 9s. That means it can happen in 4C2 ways. 4C2 into 2 success, that means P into P, and 2 failures, Q into Q. Probability of 3 9s, that means out of the 4 trials, you need 3. You have to select 3 in 4C1 way, 4C3 or 4C3 ways, P cube into Q, and 4 Qs, that is P square 4. If you simplify that, this is the answer. Two marbles are drawn in succession from a box containing 10 red, 30 white and 20 blue marbles, and 15 orange marbles, actually is not balls, with replacement being made after each drawing. That means you are drawing a ball and you are putting it back into the box, right? Find the probability that both are white. We have done that like twice. We have taken a marble, observe the color, put it back in the bag. Take the second one, observe, put it back in the bag. Like that we have done twice. So what is the probability that both are white? First is red and second is white, and neither is orange. Say for example, we have in the box 10 red, 30 white and 20 blue balls and 15 orange balls. The total is 75. So probability of first ball, and 1W means first draw white ball. What is the probability of first draw white in the first draw? Okay. So totally 75 C1. Out of which how many white balls? 30. So 30 C1 by 75, 30 by 75. And the ball is replaced. Now again what is the total number of balls? Again 75. How many white? Again 30. So second white ball is again 30 by 75. And what I want? This should happen and this should happen. Both. When I say both, it is A intersection B. First thing. Second thing. Now, does the second draw depends on the first one? No, they are independent. and two trials are independent, and then probability and A and B, those trials are independent, then P of A intersection B is equal to P of A to P of B. So this is what we get. And then second one is, first one is red. So what is the probability of getting red? 10 C1 by 75 C1. Second ball I want white. So 30 by 75. Ball is replaced. So total number of balls does not change. So this should happen, both should happen simultaneously. So 10 by 75, 30 by 75, this comes out to be 4 by 75. Neither is orange. So orange, I don't want orange at all in the first or the second trial. So close the orange. How many balls are there? Remaining ball 60. You can get anything out of the 60, not orange. So 60 by 75 and 60 by 75. Say for example, after the first draw, the ball is not replaced. Put it in your pocket, not in the box. So in this case, what happens to the first case? The first white is 30 by 75. Good. Then ball is removed. It's not replaced. How many total number of balls? 74. How many whites? 29. Okay. So the probability of second white ball is 29 by 74. I think first ball should be white and second should be white. So product of the probabilities 30 by 75 into 29 by 74. Similarly, first ball red, second the white ball. First ball red is 10 by 75. Second should be white ball. The total number of balls changes 74. Still white is not changing. Why? Because first one drawn is red. So number of white balls still 30, though total number is 74. So 30 by 74 is the probability of getting a second ball in the second draw. The white ball in the second draw. So product of the probabilities. Neither is orange. 60 by 75. So now one ball is removed. So it's totally 74. And non-orange balls are 59. So the probability is 59 by 74. Product of these two things. 2 digits. That's a simple problem. You can do it problem. Some of the numbers you see, 2 digits are selected random from 1 to 9. The sum is odd. What is the probability that 2 is one of the numbers selected? So odds between 1 to 9, odd numbers are 1, 3, 5, 7, 9 and even are 2, 4, 6. You have to use a small logic here. Sum of 2 even numbers is always even. Sum of 2 odd numbers is also even. So for example, 1 plus 3, 4, 3 plus 5, 8, 3 plus 7, 10, 5 plus 9, 14. Sum of the even numbers, 2 even numbers, or sum of the 2 odd numbers is always even number. Okay. First option. Second option, sum of 2 even numbers is always even. Sum of 2 odd numbers is always even. Sum of 1 even number, 1 odd number, it's always odd. Is always odd. Okay. So we use that logic. If the sum is odd, what is the probability that 2 is one of them? Sum is odd. So one of them must be from this set. One of them must be this set. So how many elements are there in this set? 4. And I want this 2. Only one possibility, 1 by 4. If 2 is selected, and what is the probability of odd sum? If 2 is selected from this, then you cannot have any other number from this. Why? If you take, say, for example, 4, 2 plus 4 becomes 6, not an odd number. So 2 is already selected. So the second number that is selected so as to get a total of odd number is the remaining second number must be from the remaining elements. Okay. That's what we have. So the probability that A will be alive in 20 years is 0.7. The probability that B will be alive in 20 years is 0.5. Then the probability that they will both alive in 20 years, assuming that they are independent, P of A intersection B is equal to P of A into P of B. Simple logic. They are assuming that unless until mentioned, A living for 20 years and B living 20 years, one is in New York and other one is in Chennai, then there is no connection about their mortality. So obviously they are independent events unless until mentioned. If somebody says B, the health of B depends on the health of A, then it's a problem. Then P of A intersection B becomes 0.7 into 0.5 years. Suppose that a box contains 3 white and 2 black balls, and even with the event, the first ball drawn is black, and due to the event, second ball drawn is black, where the balls are not replaced. So probability of E1 is, that means probability of first ball being red is 2 by 5. The second one is, now this is what I mean by conditional probability. See what is happening here? The second ball drawn is black. Say for example, the ball is replaced. So it is not, again getting a black ball does not depend on what you get in the first try, because the number is not changing when the ball is replaced. We have same number of balls in the box. So the second event does not depend on the first event. But what happens when the ball is not replaced? Total we have 5 balls in the beginning. One ball is drawn, that is black ball is 2 by 5, probably 2 by 5, and it is removed. So how many balls are there now? Total 4 balls, out of which only we have one black ball. So clearly the complete picture is changing because the ball is not replaced. Okay, so that is called P of E2 given E1. So one black ball is drawn, then what is the probability of getting the black ball again? That comes out to be 1 by 4, because we will be having 4 balls and out of which one is black. So the probability is 1 by 4. So now this should happen. That means first ball should be black, second ball should be first the black తీసుకుంటే second black a probability 1 by 4. So P of E2 intersection E2 even intersection E2 is equal to P of E1 2 by 5 into P of E2 given E1, that is 1 by 4, 1 by 10. So then total probability. Total probability or the rule of elimination, this is what we call. So that E1, E2, so on and so forth, EK constitute a partition of the subspace with P of EI not equal to 0 or I equal to 1 to K. Partition means you have to understand it properly. Divide this S into subsets. Okay. Subsets in such a way that they are disjoint. They don't have any common points. And secondly, if you add all those subsets, you should get S. Okay. So for example, if you throw a die, the sample space is 1, 2, 3, 4, 5, 6. Say take set 1. Only singletons 1, 2, 3. If the union of all these subsets 1, 2, 3, 4, 5, 6 is yes. And do they have any common points? No. We can divide this S into following these two principles called a partition. Then for any event A of S, P of A is equal to sigma I from 1 to K, P of EI intersection A, this is equal to P of EI into P of A given EI. That means this P of A is subset of A. It should happen through, it may happen through, not should, it may happen through E1, it may happen through E2, it may happen through EK. You want to go to Hyderabad, that is your event A. You may go by road, you may go by flight, you may go by train, you may go by one vehicle. So many options there are, E1, E2, EK. Going to Hyderabad is the event required. Okay. So the probability of selecting a road transport, okay, and then if you select the road transport, then what is the probability of reaching A? If you select rail, then what is the probability of reaching Hyderabad? If you take air, then what is the probability of reaching? So you add all those things, all possibilities. That means why it is called total probability is we consider all possibilities, all ways, methods of reaching the final event E. It may through E1, it may through E2, it may through En. Then you have to consider all the probabilities. So that's why you get summation of PEI given A given A. So pictorially, you want to go to A. So you have different paths going via E1, via E2, via E3, via E4. That means first you have to select the path E1 or E2 or E3 or E4, maybe road or transport or trail or fair or maybe air or whatever it is. Then what is the probability of selecting this path? And then once you select this path, what is the probability of reaching A? This is what we have like this. So there are 3 similar boxes, box 1, 2, 3, each one having some configuration of red, white and blue balls. A box is selected random now. They're all very much similar. You don't know which one is which, and you close your eyes and select one of the boxes. What is the probability that the ball that is selected is right ball, a white ball, or a blue ball? Question now, what is the box we are selecting now? If all the boxes have the same number, that's a different story. But all the boxes have different configurations and different formulations, right? So, first probability of B1, B2 or B3 is same because there are similar boxes. We have equal chance of selecting any of the boxes. So, P of E1, if you call E1, E2, E3 the events of selecting boxes B1, B2, B3, then P of E1 is equal to P of E2 is equal to P of E3 is equal to 1 by 3. So, now let R be the event of selecting a red ball. Okay, that red ball may occur from box 1 or box 2 or box 3. So if the first box is selected, that means probability of E1 into, if the first box is selected, what is the probability of getting a red ball? Total number of balls is 10 in this first box. Red balls is 2 in the first box. The probability of getting a red ball is 2 by 10. That is called E1. That means B1 box. Given that we have selected B1, what is the probability of getting a red ball? Similarly, if B2 is selected, second box is selected, what is the probability of getting a red ball? So these are the conditional probabilities, and some of the conditional probabilities gives you total probability. So this is what we get here. Okay. Yes, this is over, and 10th. Yeah, what is the probability of getting a white ball? Similarly, P of E1 into P of W given E1. That means you select a first box first, and then white from the first box. You select the second box and white from the second box. Second, select the third box and get a white from third box. So this is how we get the total probability. Similarly, P of blue balls, you can do it. Then comes Bayes' theorem. Total probability and Bayes' theorem, two opposite concepts. Both the things, they appear to be like the same thing, but they have completely different directions. So let E1, E2, EK be mutually exclusive events of which one must occur. Then for any event A of S such that P of A is not equal to 0, P of first let us understand the geometry. If you just go back once to the previous diagram, what we have seen is this thing. Okay. We have different possibilities of reaching A, and all the different combinations, they are contributing to the probability of A. This is the first understanding. Now what is happening? We have reached A. Then we are trying to trace out in which way we have come. Okay. So you have reached Hyderabad and your brothers asked you, how did you come? And before going there, what is happening? You have air facility, you have transport, car, rail, everything, and you are now somehow you have to reach Hyderabad. Either car, either train, either bus, either flight, whatever option you take. What is the probability of reaching A? That's your part. Once you go there, your brother asks you, yes, hi, how are you? And how did you reach? Then you want to find the probability. If you want to calculate what is the probability of arriving by train, flight, car. So from that side to this side. So direction change, that's why I said A is reached, then you are finding out the probabilities of achieving A through E1 or E2 or E3. So that E1, E2 is mutually exclusive events of which one must occur. Then for any event A of S, P of ER, probability of E1 given A, given that you have reached A, what is the probability that you have come by car? What is the, given that you reached Hyderabad, what is the probability that you came by flight? What is the probability that you came by train? These are the things that we discuss. The formula is given by P of ER into P of A given ER by total probability. That's what we call Bayes theorem. So we have some close link between this Bayes theorem and total probability. Total probability, we have different options and then find the total probability of an event. In Bayes theorem, the final event, the happening of occurrence of the final event is given. Then what are the probabilities of the paths taken? That is quite opposite direction, these two concepts. So let us say companies A, B, C produce 30%, 45%, 25% of the cars respectively. It is known that 2%, 3% and 2% of the cars produced from A, B, C are defective. And what is the probability that a car purchased is defective? See, simple example, I have given both the problems. Let us see. So the companies A and B and C have some shares in the market, right? 30%, 45% and 35%. Okay. And 2% of A and 3% of B and C, 2% of C are having defective things. Now, question now, you have purchased a car and it is defective. What is the probability it is defective? You don't worry about A or B or C. What is the probability that it is a defective one? That's the question now. So P of A is 0.3. For P of B, selecting of P is 0.45 and 0.25. And the defective is 2%. That means from A it is 0.02. From B it is 0.03. From C it is 0.002. What does that mean? That means if the car you have purchased is from A, is manufactured by A and it is defective. It is manufactured by A and it is defective. That is 0.02. The car that is found to be defective is manufactured by B and it is defective is 0.03. It is manufactured by C and it is defective and it is defective is 0.02. These are the probabilities we have. So whether it is from A or B or C, don't matter, don't mind. Your question is what is the probability that it is defective. So it can be from A or it can be from B or it can be from C. So selecting A is 0.3 into once A is selected, what is defective is 0.02. Selecting B is 0.45. After selecting B, what is the defective? That is 0.03. Selecting C is 0.25 and once it is selected, what is the probability it is defective? That is 0.02. We add up all these things, we get 0.0245. So what we are doing? It may be from A, it may be from B, it may be from C, but finally, what is the probability that is defective one? That is total probability. Coming to the second problem, if a car purchased is defective, the final outcome is there. What is that? It is a defective car. Now you want to punish that fellow. And what is the probability that it is manufactured by C? What is the probability that it is manufactured? The final event is there. What is that? It is defective. It is proved. It is observed. Then we want to know who is the culprit. Right? So it is given that defective. What is the probability that it is manufactured by C? That is what is reverse direction. C given D. So P of C into P of D given C by the total probability. So it comes out to be 10 by 49. Then we come to, these are the basic probability concepts that we require. Then we come into, gradually we are entering to statistics. It starts with random variable. So what is a random variable? You have to first understand the idea of random variables first. So when we have sample space and we define the random variables on the sample space. Let us be a sample space and a random variable x on S is a function from x from S to a real number. That means to each event of S we assign a real number. To each event of S we assign a real number and that's what we call a random variable. So that is, to each element S belonging to S, X assigns a real number called X of S, and it will denote this random variables by capital letters and the value of the random variable by a small letter. Say for example, if you toss two coins, we have seen that the sample space is head, tail, head, and tail, tail. And to each element of this sample space, we assign a specific number by defining X. For X, if I define now, X has the number of heads. Okay. So if X is denotes number of heads, if you take the sample space, then what is the first element of sample space? Head. So what is the X value for the first element? Number of heads in the first element? 2. What is the second element? Head, tail. How many heads we have? 1. What is the third one? Tail, head. What is X value? 1. The last element in S is tail. How many heads? 0. So X we are defining, for each element of S we are defining a real number as 2, 1, 1, 0 for the given example. So that's a random variable. Defined on the sample value, sample space, 2 real numbers. So random variables are denoted by capital letters and their values are denoted by small letters. That is it. Now, depending on the type of experiment we are conducting, the random variables are classified as into 2 categories: discrete random variables and continuous random variables. Discrete random variables and continuous random variables. What are discrete random variables? A random variable is said to be a discrete random variable if its sample space is countable or countably infinite. So you have finite number of values in the sample space, then we say it as discrete random variable. And if it is not so, it's infinite number of. See what all probable distributions, binomial distributions, Poisson distribution, and what all the different things you have done in probability in our intermediate level, they are all basically the problem of throwing a die, drawing a card from pack of 52 cards. When you draw a card up, one card from pack of 52, you have only 52 options, finite. Okay, all these examples, when you throw a coin for 100 times or 100 coins, you toss them, then you have 100 different possibilities. They're all finite thing. If it's not finite, then we say it is a continuous random variable. Say for example, in our laboratory, you conduct an experiment. Say for example, in the chemical laboratory, you conduct an experiment. You want to find out the morality, what is the molecular weight or morality, you find it, no? In our laboratory. And you have some accepted values, let us say 10 to 11 is acceptable reason. But between 10 and 11, you can get any value. How many values between 10 and 11? You can expect. There can be infinite number of possibilities we have. Okay. You have, say for example, civil engineering students, you go for survey, soil mechanics, and you want to go for groundwater systems, and you want to find the different components you want to study in the earth soil testing, right? So some ratios are there, prescribed ratios, healthy ratios. So in that neighborhood, if you get some value, you said okay. So how many possible values are there? Let us say it is some particular parameter, 10 is correct value. If you get anything between 9.5, 10.5, we accept it. Okay. How many values are there between 9.5 and 10.5? Infinite number of values you may get for a given sample. So there the sample space is having infinite number of possibilities, elements. So that's why they are called continuous random variables. Now once these random variables are classified, then we define the probability distributions. So whenever we discuss probability distributions, depending on the classification of random variables, we define the probability distributions once for discrete distribution, discrete random variables, and once for continuous random variables. They are completely different. So first we see discrete probability distributions. Each event in S has a certain probability of occurrence. We have already discussed that definition of probability is for each element we assign with a quantity, real number. So each event in S has certain probability of occurrence. Then a representation of the possibilities, representation of the possible values of the random variable and their probabilities. So you take, because discrete means we have finite number of values, you take the values of X like this and then their probabilities. That's a representation. That representation is a probability distribution. The representation can be in a tabular form, it can be a graphical form, it can be a function form, in the form of a function, in so many ways. It can be in a pictorial form, maybe a scatter diagram, it can be in so many ways. The representation, anything can be called as a distribution. So here each the representation of the possible values of X together with the probabilities is called a discrete probability distribution. Generally we call this as f of X is equal to probability that the random variable takes a value X. So the probability distribution satisfies the following properties. One is fx must be always greater than or equal to 0, and the second one is the total probability must be equal to 1. If your function, if this f of x does not satisfy any of the properties, then it cannot be a probability distribution function. So it must satisfy these two properties. Nothing so new here. The probability must be always greater than or equal to 0. It cannot have negative value, and some of the probabilities is equal to 1. So they are called the properties satisfied by required to be satisfied by distributions. And in case of continuous random variables, how it happens? Distribution. What do you mean by distribution for a continuous random variable? For a continuous random variable x, the function f of x satisfying the following conditions is known as the probability density function. Probability density function. Okay. So what are the properties? F of x here also, because it's a probability, it must be greater than or equal to 0. Now in place of summation here we are using integration. Why? Here we have finite number of values. It's a continuum. It's an over interval, because we have, as I said in the example, 9.5, 10.5 is an interval, is not discrete values. So in place of summation we get integral, we use integral minus infinity f of x dx, because for that there is a lot of theory. Just I am giving empirical formula. Minus infinity f of x dx is equal to 1, and probability of a less than x less than b is equal to integral a to b f of x dx. So this is called probability density function, PDF. So let us say it's a continuous function, so it can be represented with a smooth curve like this. This is x and this is fx. This fx can be expressed as a smooth curve like this, and we know that probability of a less than x less than b is integral a to b f of x dx. From the basics of calculus, integral a to b f of x always represents the area bounded by this curve y is equal to fx, x-axis, x is equal to a and x is equal to b. So the shaded parts gives the area. Now see the beauty here. When we started learning this probability, we thought it's a very abstract idea. Now here, once you define the probability of a less than x less than b as integral of a to b f of x dx, then we are getting it as an area bound by curve. It is very much geometrical, it is very much physical. Okay. Now one more important thing in continuous probability distributions, it is not the case in discrete case. It is a very important point in discrete distributions. What is that? That is P of A less than x less than b is equal to P of A less than equal to x less than equal to b is equal to P of so on and so forth. That means it is open interval or closed interval, immaterial. Inclusion or non-inclusion of the endpoints does not affect the probability. Why? Because in continuous case, point probabilities are always 0. Say for example, I take a small needle, I put it on my paper. Okay. Can you say it's a point? What do you mean by point? A point means a circle. If you say, if you can draw a small element, maybe interval, if you consider a small interval, interval of zero length is a point. So when you take a pin, needle and put it on a paper, can you say it is a zero? It occupies a zero area? No. However small, it does occupy some interval of length. So it happens in both the cases, spatial coordinates and time coordinate also. You cannot do anything in zero interval. However brief you are, okay, however how much laconic you are, you cannot start and end the speech in zero time interval. It never happens, it's not possible. Maybe macrosecond, maybe nanoseconds. Same thing in spatial coordinates also, you cannot have anything in zero interval. So at x is equal to a, you cannot do anything. Exactly at x is equal to a. So endpoints or inclusion of endpoints and non-inclusion of endpoints will not affect the probability. That is a reason for that. So when you want to find the probability of x is equal to a, what we do is we consider a small interval about that point, a minus delta x to a plus delta x, then integrate the function between a minus delta x to a plus delta x, find the value, and then take delta x goes to 0. And you can prove that it always goes to 0. It becomes 0. As limit delta x goes to 0, integral of f of x between a minus delta x and a plus delta x always becomes 0. This probability at points in continuous distributions is always 0. In discrete distributions, it's not so. It's only in continuous distributions, point probabilities are always 0. Miller and Freud say that there is a wonderful statement. In continuous distribution, point probabilities are 0, but they don't mean logical impossibility of the event. P of x is equal to 0. In general, we say the event never happens. Impossible event. Okay, whenever probability is 0, we call it as impossible event. When probability is 1, we call it as certain event. It happens, it must happen when probability is 1. So in continuous distributions, 0 probability does not mean the logical impossibility, because at a it is happening, but you cannot find the probability at a it becomes 0. That you have to understand. Very intricate, sensitive point, you have to understand that clearly. Then cumulative distributions. For a continuous random variable x with probability density function f of x, the cumulative distribution capital F of x. So see, the density function is denoted by small fx, and the cumulative distribution is denoted by capital F, and the density function is small f. Is defined by capital Fx is equal to P of x less than or equal to x. That means integral minus infinity to infinity f of x dx. There as a word says cumulative distribution. That means what it gives is from the starting to till this point, what happened? The total probability. That is what we mean by cumulative. From the beginning to this extent, or the end point, given point, what is the total probability? Add up all the probabilities. Okay, that gives you cumulative. What is the maximum value of this function capital X? Because the total probability at the most can be equal to 1. So the capital F of x is for x less than or equal to x is defined as minus infinity x, that means up to x, what is the total probability, summation of all the probabilities. So if x is equal to minus infinity, that means f of minus infinity, that means starting with minus infinity and ending with minus infinity. So we are going nowhere, the probability becomes 0. The cumulative probability becomes 0. And if you go to plus infinity, minus infinity, that means we are completing the complete real line, that gives you total probability 1. So clearly it says that 0 less than or equal to f of w, cumulative distribution f of x less than or equal to 1. And if you differentiate this, one more important property, f dash x is equal to f of x dx. That is the relation between cumulative distribution function and probability density function. This is a wonderful question can be asked on this. Point probabilities, you have closed intervals and open intervals, they can ask questions on that. Here also, if small fx is the density function, and density function and cumulative density function are related by small f dash is equal to capital F, capital F dash is equal to small f, capital F is equal to small f is integral of f. 4 options we have. Don't get confused. Small f means probability at a point, okay, between two numbers. Whereas cumulative is from the beginning to the given point, the total probability, that is cumulative. And whenever P of A less than or equal to X less than or equal to B, that is means calculate the probability from minus infinity to B minus infinity to A, f of x dx. So this is called f of B, this is called f of A. So f of B minus f of A gives you the probability of x lying between A and B. Mind you, here as I told you, here it is closed interval or open interval, it does not matter in continuous distributions. That's why as a general case, I have written A less than or equal to X less than or equal to B, but it does not matter. As I said here, the point probabilities are zero probabilities. Whether you include the endpoints or not, it makes no difference for us. Then comes expectation. Once the distribution is defined, then comes the expectation. As at the very beginning we said mean and dispersion of measures of location. So I said when data is given to you, if you know the location, you can have some idea about the distribution. The same concept here. So there some numbers are given, but here some probable distribution is given. The difference is there some numbers are given, you calculate mean, mode and median. Here what you are doing, some data probability distribution is given. That means the elements of S have some probabilities. That means chance mechanism. So the chance mechanism that makes the difference, the set of numbers to probable distribution. When we have some sample space, random variable and some probable distribution, then we talk about the expectation. The behavior of random variable x, either continuous or discrete, is characterized by distribution function. Distribution function, that is, we are calling it as small f and capital F in continuous case, maybe density function, cumulative density function in continuous case, and P of x in case of discrete case. The behavior is studied by using this density function, cumulative density function, or maybe probability distribution. So expectation or mean, both words are synonyms. They can use either expectation or mean, it makes no difference, either thing. Of a random variable x, it is denoted by E of x. Expectation means E of x or mu. E of x or mu means mean. Mean of a random variable x is defined as, actually in books they have different chapters like for discrete distribution, continuous distribution. To make this talk as brief as possible, I am putting both the things at the same time, even presenting you both the things at a time. So in discrete, if x is a discrete random variable, mu is defined as summation of xi f of xi. Xi is the random variable and f of xi the probabilities. In case of continuous random variable, it is minus infinity to infinity x into f of x dx. As I said, in continuous random variables, they are not finite. It's a continuum interval, so we will always use minus infinity to x into f of x dx. So if x is equal to x is a median, now we have to define everything. Now once we have probable distributions, the mean, mode, mean we have defined sigma x and fx. We have to define mean, mode, everything in terms of probable distributions. That means in terms of the probabilities. So if x is equal to x is a median, if probability of x less than capital X less than x is less than or equal to 1 by 2, probability of x greater than x is less than or equal to 1 by 2. That means total probability is 1. X, any probability of any value less than x is 1 by 2, greater than x is 1 by 2. What do you mean by that? Probability of x is exactly lying in the middle point. To this left is 1 by 2, to the right is 1 by 2, and total is 1. So that means this point is exactly in the middle. That's why we call it median. In terms of distribution, equal chance, I mean on either side you have equal chances. So then mode, if P of X is equal to X, what is the mode? The number which occurs maximum number of times. So when you conduct an experiment for 10 trials, the same value comes 8 times. What is the probability of getting that value? 8 by 10. Okay. So maximum number of times it is occurring. So the probability is maximum for that. So X is equal to X is mode for which Fx or P of X attains maximum value. So these points are very, very important because the mean, mode, and we're getting some questions on that. Some probability distribution may be given. They may be asking you what is the median and median. Mode and median, and of course mean you can calculate sigma x fx in or minus infinity x into f of x dx. Then, as I said, there are also deviation, measures of dispersion. Here we are also calling it as variance and standard deviation. Variance of a random variable x is denoted by sigma square. It is defined as sigma square is equal to expectation of x minus mu whole square. Just observe the concepts. If x is a random variable, expectation of x is called mean, expectation of x minus mu whole square is called variance. This is, whenever I say expectation, the random variable into the probability, sum up all this, the products of the random variable and the fx. What is the random variable here? Not x, x minus mu whole square. So sigma, in place of x we get x minus mu whole square, that's all. So sigma x minus mu whole square into f of x. If x is discrete and if x is continuous, sigma square is minus infinity x minus mu whole square into f of x dx if x is continuous. Then standard deviation, it is denoted by sigma positive square root of sigma square. Positive square root of sigma square, we call it as standard deviation. We have some other formula for sigma square. There is expectation of x square minus mean square. E of x square minus mu square is a proof. We don't need that here. Sigma square you can calculate either using this formula or this formula. In case of discrete case, this becomes sigma x square fx minus mu square. Integral x square fx minus mu square. It may happen. It can take either integral term or this term depending on x. So we have some properties. Expectation of k times, if you have random variable x and you have expectation of x is known to you. If the random variable is defined multiplied with a constant k, all the values of the random variables are multiplied with k, the same number k, then what happens to mean? It is k times expectation of x. These things we are getting very nice questions on this. Please remember this formula. Expectation of kx is k times expectation of x. And expectation of x plus k. Okay. If for each value of the random variable we add some value k, that becomes expectation of x. In fact, in the examination result process and in national level examination and huge number of students write the examination, in the moderation, if they want to conduct, some universities conduct the moderation, he adds some 1% or 1.5% to each student so that the mean also shifts forward by an amount k. Okay. Then expectation of x plus y, x and y are two random variables. Expectation of x plus expectation of y is expectation of x plus expectation of y. And then coming to similar properties in terms of variance, variance of x plus k is equal to variance of x. So if we add some constant to the variable, its location is changed. If you add 1 to 5, as for example, data is 5, 6, 7, 8, 9, 10. If you add 1 to each of the elements, the data becomes 6, 7, 8, 9, 10, 11. So from this to this, it shifts by 1 unit like this. That's all. Variance will not change. Variance means the difference between the mean value and from it how much they are spreading both sides. That is what we measure here. So it will not change. Okay. So it will not change. Variance of x plus k is also equal to variance of x. But variance of kx, if you multiply each x with k, then it changes. That becomes k square into variance of x. A player tosses 3 fair coins. He wins rupees 100 if 3 heads occur. It's a gambling game. 300 if 2 heads and rupees 100 if one head occurs, and also he loses 1500 rupees if 3 tails appear. Find the value of the game or expectation of the player. So if x is discrete random variable and x be the number of heads occurring, because the issue is the whole problem is with the number of heads, call the x as number of heads. So your sample space will be, because 3 coins are tossed, head, tail, HTH, HTT, THH, THTD, TTH and TTT. These are possible 2 cube 8 outcomes. So we have options 3 heads, 2 heads and 1 heads. What are the probabilities? Then probability of having 3 heads, x is equal to 3. That is how many times we have? We have 1 out of 8. Probability is 1 by 8. Probability of 2 heads, see, 2 heads, this is 1, this is 1, and then there was something else, 1, 2 and 3. So 3 possibilities we have. Probability of having 2 heads is 3 by 2, and probability of 1 head, if you see, is 1, 2 and 3, 3 by 8. And probability of 0 heads, all are tails, that's the only possibility, so 1 by 8. So the distribution now is x is number of heads is 0, 1, 2, 3, and distribution is probabilities are 0 heads 1 by 8, 1 head 3 by 8, 2 heads 3 by 8, 3 heads 1 by 8. So expectation is sigma x into fx. X means the amount he stands. So 500 into 1 by 8 plus 300 into. So if 0 heads, you loses. If he gets all the 3 heads, he gets 500 rupees. If you get only 2 heads, he gets 300. What is the probability of getting 2 heads? 3 by 8 into 300 rupees. Only probability of only getting 1 head, the probability is 3 by 8. What is the amount he stands to win? 100 rupees. And what is the loss he is going to get? If all are tails, 0 heads, the probability is 1 by 8 and the amount he wins is 1500. Loses is 15 minus 1500. So if you add up all those things and 1500 1 by 8, generally if I ask the same problem, if I toss a coin, let's say simple problem, if I toss a coin I get 10 rupees, if I get a tail I lose 5 rupees. If I ask the question to anybody, what is the probability, what is the expectation, they simply say 10 minus 5, that is 5 rupees. Because in the experiment if I win and I am getting 10 rupees, if I lose 5 rupees, then 10 minus 5 is my expectation. It is wrong. You have to multiply with the probabilities, then only you get the expectation. The daily consumption of petrol is a random variable having PDF, so on and so forth. It's a continuous distribution. This is a discrete distribution. Why? How many values are there? 4 possibilities, finite. But whereas here, fx is equal to kx into e power minus x by 2 for x greater than 0. When I say x greater than 0, how many possible values? Infinite. So this is what we get. So if you integrate and if equate this to 1, because total probability must be equal to 1, if you equate this to 1, you get the value of k as 1 by 4. So next one is, what is the mean? Mean is 1 by 4 sigma x into fx. So if you calculate, I get the value of mean. Probability distribution is given by x is 1, 2, 3, 4, 5, 6. P of x is 11k, 9k, 7k, 5k, 3k, 3k. What is the find k, mean and variance? When you want to find the mean and the value of k, you add all the probabilities. Total probabilities always must be equal to 1. So 11k plus 9k plus 7k, 5k, 3k plus so on and so forth. If you add all of those things, you get 36k. It must be equal to 1. So k becomes 36, 1 by 36. So distribution is now, put this 1 by 36 here, 1, 2, 3, 4, 5, 6, 11 by 36, 9 by 36, so on and so forth. So expectation is x into fx. So 1 into 11 by 36, 2 into 9 by 36, 3 into 7 by 36. I'm sorry, it is 3 into 7 by 36, 4 into 5 by 36, 5 into 3 by 36, 6 into 1 by 36, 2.5. When you want to calculate sigma square, as I said, another formula for variance. This one, expectation of x square minus mu square. Expectation of x square means x square into fx, x square into px. So 1 into 11 by 36, 4 into 9 by 36, 9 into 7 by 36, 16 into 5 by 36, 25 into 3 by 36, 36 into 1 by 36, minus mu square, 2.5 square, you get this. So Once we have the basic introduction of the distributions, now we have some theoretical distributions, binomial famous distributions, very popular distributions, binomial distributions, Poisson's distribution, and we see normal distributions also. What is binomial distribution? First, we can understand Bernoulli trials to understand binomial distribution. When do we say that the trials are Bernoulli trials? An experiment is repeated n times and they are called Bernoulli trials if each experiment has two outcomes. Each experiment must have only two outcomes. We call them success and failure. Second one is probability of a success or probability of a failure throughout all these n trials, it must be constant. So in the first trial, let us say p is equal to 0.1. Even for the 100th trial, p must be equal to 0.1. So the probability should not change from trial to trial. Just like tossing a coin. 100 times, whatever result you get, next time when you toss the coin again, probability of getting head is again still is 1 by 2. Or probability of tail is again 1 by 2. It does not change. The third one is all outcomes are independent. 100 times you get a head when you toss a coin 100 times. Can you say next time you get tail or next time also you can get head? No assurance. So first time you get head, second time there is no guarantee of getting head. It will not depend on the previous history. So all outcomes are independent. That's what we call them. So if these three conditions are satisfied, then these trials are called Bernoulli trials. I repeat the condition. What are those? Each experiment has only two outcomes. We call them success or failure. The second one is probability of a success or failure is constant for all trials. The third one is all outcomes are independent. All trials are independent. So such trials are called Bernoulli trials. Then a binomial random variable x is the number of successes in Bernoulli trials. It is discrete. See the other way of defining binomial variable. Binomial random variable x is the number of successes in Bernoulli trials. So trials must be Bernoulli's. If you have Bernoulli trials, the number of success, that is called binomial random variable. So it is discrete. So binomial distribution is a probability distribution of such a binomial random variable which gives the number of success in Bernoulli trials, and that is given by denoted by bx and p is equal to ncx b power x into q power n minus x, where p is the probability of success in each trial and q is the probability of failure in each trial, and because only two outcomes, success and failure in each trial, p plus q is equal to 1 or q is equal to 1 minus p. And total probability, binomial probability must be equal to 1 because it's also a probability distribution. Sum of the probabilities, total probability must be equal to 1. So mean and variance of binomial distributions are mu is equal to np and variance is npq. Assume that 50% of all engineering students are good at mathematics. Find the probabilities that among 18 students, exactly 10 or at least 10 or at most 10 and other things are good at mathematics. So 50% of the students are good. What is the probability? 50 by 100, 0.5. So Q is also 0.5. How many students are now tested? 18 students. Okay. How many are required to be good? 10. Exactly. What is the probability? Exactly 10 are good. So X is 10. Mean that is successful. Success. The number of success 10. So Bx and P is equal to 18Cx 1 by 2x 1 by 2 18 minus x. P and Q is equal to 1 by 2 1 by 2. So exactly 10. 18C10 1 by 2 power 10 1 by 2 power 8. So greater than or equal to second question, at least 10 means 10 or more. So from x from 10 to 18, 18Cx 1 by 2 power x 1 by 2 power 18 minus x, so on and so forth. So a binomial distribution has mean 2 and variance 4 by. This is another standard type of questions that we are getting in the examinations. Mean 2 and variance 4 by 3. Find the distribution. So in binomial distribution, mean is NP and variance is NPQ. So mean is NP is equal to 2 given and variance is NPQ given as 4 by 3. If you divide this NPQ by NP, NPQ by NP is equal to Q. If you cancel NP, remaining is Q, and 4 by 3 by 2. So it is 2 by 3. So what is the Q value? 2 by 3. So what is P? 1 by 3. Now what else we have to, what you have to get? Because NP is 2, now we have to get N value. P is known, NP is 2, so N is equal to 2 by P, where P is 1 by 3, so N is 6. So if you know these two things, mean and variance, you can get N also. So your distribution now becomes NC6, C is C6, P power X, P is 1 by 3 power X, Q is 2 by 3 power 6 minus X. This is your distribution now. Now, if you put X is equal to 0, 1, 2, 3, 4, 5, 6, you get all the probabilities from this. Now we can talk about Poisson distribution. If it is also a discrete probability distribution, random variable is discrete, and having a distribution function P of X is equal to X is lambda power X e power minus lambda by X factorial. Lambda power X into e power minus lambda by X factorial, where X changes from 0, 1, 2, so on, so forth. Then lambda is always positive parameter, and it is called Poisson's parameter. It is called Poisson's parameter. Its value is lambda is equal to N into P. So when do we apply this Poisson distribution? We apply this Poisson distribution when P is very small and N is very large. So large and P is so small that N into P goes to 0. N into P goes to 0. So mean of the Poisson distribution is NP. Variance is also equal to NPQ. Mean and variance are equal for Poisson distribution, NP and NPQ. Find probability P that there are 3 defective items in a sample of 100 items if 2% are defective. How many are sampled here? 100 items. What is given? Find the probability P that there are 3 defective items. So X is 3. Defective items X is 3 is given. Total number of is 100. N is given. What else is given? If 2% are defective on average, in general 2% of items are defective. So when I say an average, so lambda is NP. So in general it is 0.2, 0.02, 2% means 0.02. For 100 it is 100 into 0.02, that comes out to be 2. So P of X is equal to 3 is e power minus lambda power X by X factorial, where lambda is equal to 2. If you put e power minus 2, 2 power 3 by 3 factorial comes out to be 0.18. And there are very frequent questions on Poisson distribution are like this. It may be the average number of phone calls received, an average number of maybe what is that ambulance calls, average number of received calls at counter, how many number of checks received in a bank. These are the standard, how many covers or letters are received by a courier service. These are the type of problems that we generally come across in Poisson's process. The average number of calls per minute received at a counter between 2 and 4 p.m. All this data is not necessary. Is 2.5. This is important. Find the probability that during a particular minute there will be 0 calls or 1 call or 3 or less than or equal to 4. So the average number of calls is given as 2.5. What is the average number in Poisson means? Lambda is given, that is 2.5. And then f of x lambda is e power minus lambda x by lambda power x by x factorial. So everything is almost all given to you. Lambda is once you know lambda. So this is e power minus 2.5 power x by x factorial. X is the number of calls, whatever is asked in the examination, in the problem. So if you want to find f of 0 lambda, that means 2.5 power 0, 1, x factorial becomes 1. So the probability is e power minus 2.5. So if you want only 1 call, then x is equal to 1. E power minus 2.5 by 1 factorial. If you want 3, so on and so forth. If you want less than or equal to 4, means 0, 1, 2, 3, 4, all the possible things. That means x from 0 to 4, f of x 25. This, if you calculate this, you get the Poisson distribution. Then we have normal distribution. It is a continuous random variable. It's a very powerful aspect. It's a continuous random variable. It is a distribution of A continuous random variable called a normal variate or normal variable, denoted by this normal distribution in general denoted by n of mu sigma. Mu is the mean, sigma is the standard deviation, and this f of x is defined by 1 by sigma root 2 pi e power minus 1 by 2 x minus mu whole square by sigma. This is a very complicated thing. We will simplify the terms later on. Properties. If you consider the property, the graphical representation of this, the geometry of this, it's called a normal curve, which is a bell-shaped curve like this, a bell in the temple. Okay, like this. Symmetric about y-axis. Okay. Mean, mode, median, they coincide. Mean, mode and median coincide. So it is unimodal distribution. It's a unimodal distribution. Area on the total curve means total probability is always equal to 1. Probability that x1 less than or equal to x less than or equal to x2 is integral x1 to x2 of this function. So, but this is in practical aspects, it is a difficult thing because for different distributions, mean is changing, variance is changing. So, when you have two varying parameters, it is very difficult to compare two or more different distributions. That is a problem with normal distribution. So, some of the parameters we have to make them uniform. Then only you can compare different distributions. For that, we define standard normal distribution. Here what we do, whatever big thing we have in the exponential term, that is x minus mu whole square, x minus mu by sigma whole square, call that as some z. So if you put z is equal to x minus mu by sigma, then in normal distribution, then 1 becomes, z1 is, the x1 is now converted using this formula. So z1 becomes x1 mu minus mu by sigma, where mu and sigma are mean and standard deviation of x. Okay, and z2 is equal to x2 minus mu by sigma. So expectation of z now, expectation of when we add some quantity to each random variable, what happens? Each value of the random variable, mean will not this thing, e of x minus mu. Okay, so this becomes e of x is mu, so mu minus mu is 0. So variance, what happens? Variance of kx is k square into variance of x. So the variance of 1 by sigma of x is 1 by sigma square variance of x, that is sigma square becomes 1. So by doing so, z is equal to x minus mu by sigma. Now what is the expectation of new random variable? 0. What is the variance of new random variable? 1. So whatever x you take, you convert that into z using x minus mu by sigma. Now then new random variable is having 0 and 1. So if you have two different distributions now with means mu1, mu2, sigma 1, sigma 2. Now convert both the distributions into z using x minus mu by sigma. This is y minus mu by sigma. So when you convert both the distribution into z, both will have mean 0 and variance 1. So then you can compare conveniently. So with this structure, this 1 becomes x1 reduces to becomes z1, x2 becomes z2. Probability of z1 less than or equal to z less than or equal to z2 is integral z1 to z2. This sigma is 1 by root 2 pi e power minus this is z square by 2 dz. So this is called standard normal distribution. And this is because in general it is denoted by n mu sigma, right? What is that? N mu sigma for any random variable. In standard normal variable it is n 0 comma 1. Why? 0 is mean is 0, 1 is variance. The mean and variance of z are 0 and 1 respectively. So what about this geometry? Normal distribution have a bell-shaped curve. What about standard normal distribution? Because the shift of origin here is happening. X minus mu by sigma is, so here, so we are taking this z is equal to x minus mu by sigma. Mu and sigma are constant. So x by sigma, so kx plus ax plus b is in the form ax plus b. So that means the origin is shifted, a sort of thing like that. Okay, if you imagine that way, and you shift the origin, geometry will not be affected. So standard normal curve is also a bell-shaped curve, symmetric about y-axis. Only thing is mean is 0 and variance is 1. Mean and mode and median here also coincide, and it is also unimodal. area under the curve is 1. The marks obtained by 1000 students in mathematics is normally distributed with mean 78% and standard deviation 11%. How many students got above 90% of marks? Okay. So Z is equal to x minus x bar by mu. So x is given, x bar is 0.78% means 0.78 and standard deviation is, sigma, this is sigma, is 0.11. So what we want, more than 90 marks, and x is 0.9. So what I want is probability x greater than 0.9. Probability how many students got above 90%. So for that, first you have to calculate P of x greater than 0.9. So P of, convert this x into z, z is equal to 0.9 minus 0.78 by 11. If you use this formula, you get 1.09. Okay. So Px greater than, probability of x greater than 0.9 means probability of z greater than 1.09 in terms of z. So this is the curve. We are not discussing standard normal tables because time is not enough. I still have 9 minutes time. I have to finish off my presentation. I have still almost at the end. We have to see the examination papers. Okay. From the tables, if you get f of 1.09 cumulative distribution, f of 1.9 on the tables, you get this the final answer. So this is the probability that x greater than 0.9. So how many students do we expect to cross this 90% mark? This is out of total 1000 students. That is 1000 into 0.1379. That approximately 137.9. You cannot have 137.9 students. So you can say approximately 138 students. So similarly, the other problems are like this because we need to have this standard normal tables. Otherwise, you cannot do these problems. That's about normal distribution. So as I promised today, in the syllabus, distribution of probability, conditional probability, mean, median, mode, standard deviation, random variables, Poisson normal, and binomial distribution. That is completed. Whatever one or two topics are specifically for one or two branches, I am not touching upon those things because if I have one more day, I can 1 or 2 days time I can finish it off, but it's not possible now for today. Okay. Let us see now what are the grade, how we are getting the previous gate papers. What are the type of questions we are getting in the, so that you gain some confidence out of it, right? After going to the session, if you just once go to the questions, previous questions, you will have some confidence. So in box there are 5 green balls and 10 blue balls. A person picks 6 balls randomly. The probability that the person has picked 4 green balls and 2 blue balls. So 5C4 into 10C2 by 15C6. You have to calculate that. So simple calculation. A fair coin is tossed 15 times. The probability of getting exactly 8 heads. So 15C8, NC binomial distribution, NCX, B power x, Q power n minus x. Assuming a probability of head is equal to probability of tail is equal to 1 by 2, 15C8, 1 by 2 power 8. You calculate that. Simple questions, binomial distribution. Probability that a 50 years flood may not occur at all during 25 years life of a project, round off. We have done these problems already. A similar problem already in this. Two sides of a fair coin are labeled as 0 and 1. The coin is tossed 2 times independently. That means is given independently as binary tiles. Let M and N denote the labels corresponding to outcomes of these tosses. Okay. For random variable x, define x is equal to minimum of Mn. Expect the value of E of x. Given that the 2 sides of a fair coin are labeled as 0, 1. Let M and N be denote the labels corresponding to outcomes of these tosses. So random variable is minimum of Mn. This is given. So x is equal to minimum of 0, 0 is 0. Minimum of 0, 1 is 0. Minimum of 1, 0 is 0. Minimum of 1, 1 is 1. So what are the values? The random variables x, 0 and 1. It's a discrete random variable. So when x becomes 0, 2 coins are Two coins are, see, question is 2 coins are tossed. Each coin is labeled as 0, 1. So in place of head, tail, you have 0 and 1, 0 and 1, right? So possibilities are head, tail, or 0, 0, or 0, 1, or 1, 0, 1, 1. So values of x are 0 and 1. So when do we have 0? This one, we have 1, 2, 3, 4 outcomes. How many times we have 0? 1, 2, 3, 3 by 4. How many times we have 1? Only one time, that is 1 by 4. So expectation is 0 into 3 by 4 plus 1 into 1 by 4. A company is hiring to fill 4 managerial vacancies. The candidates are of 5 men, 3 women. If every candidate is equally likely to be chosen, then the probability that at least 1 woman will be selected. Number of women is 5, number of men is 5, total number is 8. So when I say at least 1 woman, how many posts? 4 vacancies. How many women are there? 3 women. So all 3 women can be selected. 2 women can be selected, or at least 1 woman can be selected. So at least when I say 1 woman, your possibilities are 1 woman, 3 women, and 3 women. So this is what we get. Consider 2 exponentially distributed random variables x and y, both having mean of 0.5 and x. This exponential distribution is nothing but this one. You can take this one. We have not done exponential distribution. We have not studied. Right. Traffic on highway is moving at a rate of 360 vehicles per hour at location. If the number of vehicles arriving in this highway follows Poisson distribution, there are type of problems. The probability that the headway between successive vehicles lie between 6 to 7 seconds. Similar problem. Traffic convoy, again same problem, or similar, same thing, 2 times. The unbiased dice are thrown. Each dice can show any number between 1 to 6. The probability that the sum of the outcomes of the 2 dice is divisible by 4. So what are the possibilities we have divisible by 4? 4, 8 and 12. So you can calculate it. 12 means 3 possibilities we have. 3 by 36, that is 1 by 12. That comes out to be this thing. Suppose y is distributed uniformly in open interval 1, 6, distribute uniformly 1 by 6, 1 to 6. The probability that the polynomial 3x square plus 6xy has only real root is, so uniform distribution. If x and y are random variables such that expectation of 2x plus y is equal to 0, expectation of x plus 2y is equal to 33, then expectation of x plus y. Let us say this is expectation of x is equal to mu and expectation of x is a, expectation of y is b. So this 2a plus b is equal to 0, a plus 2b is equal to 33. So if you solve this, you get expectation of x and expectation of y, you get this value. Or else you add these 2 things, ax plus b is equal to 0, x plus by is equal to 0. If you add these things, this 2a plus a, 3 into a plus b into 2b, 3. So 3 into a plus b is equal to 33. So a plus b is equal to 11, simply direct answer. You need not even solve it. The cumulative distribution is integration. Is given by 1 minus e power minus x, x greater than or equal to 0, otherwise 0. Then probability of z greater than 2 given that z greater than 1. This is conditional probability problem. The probability of resistor being effective is 0.02. There are 50 such resistors in circuit. 2 or more defects binomial distribution. So almost all the questions are on binomial distribution. If the x is the mean of the data 3x24, then the mode is, you know how to get mean, mode and these things. Mean you can calculate x first. X is the mean of the data 3x plus 2 plus 4. So 9 plus x by 4 is equal to x. So x becomes 3. When x becomes 3, 3 comes twice. So the mode is 3. So like this, all the questions are very simple questions. Only thing is you have to apply your mind to the problem. That's all. So with this, I conclude my series of all my 12 lectures. Hope they are useful. I can understand that listening to a class for 2 hours, that means well packed and fully packed class like this, very difficult for all of you. It is very difficult. I know it, because I'm not going in a slow rate. I'm going very quickly, very briskly. So following it is very difficult. Each class, it takes minimum 2 days time for you to prepare. Minimum 2 days time for you to revisit and learn thoroughly. All of you listen to my lectures once again. You will get all the basic concepts to crack the gate. They will not go beyond this. 90% of the case problems, they are within our discussion only. That's why I'm putting my gate question papers also, previous problems on the previous gate question papers. You see that almost on all the problems we have discussed in our regular class. If not the numbers may be changing, but similar types. So don't be panic about this mathematics in gate examinations. You can do it very well. You practice well. I wish you all the best. I wish all you should get in good institutes, PG, MTech seats and IICs and IITs and NITs, and come out with great flying colors in life. God bless you. All the best.